Mom, am I audible?
Yes, sir.
So we are going to start this D and F block. Last class you were absent, right?
Yes, I was.
So first of all, I'm going to introduce this D block, then I'll show you this D block. Okay, just wait a minute. Okay, Humam. So this D block elements, just wait a minute. Yes, Humam. So basically we need to do this D block. So what is D block? D block elements. See this D block elements. So how you are going to define S block element, P block element, and D block element? So basically, you have already studied this in class 11 periodic table. First, you are going to do the electronic configuration of any element. If the last electron enters into the D subshell, that is that elements belong from D block. If it is in neutral state, not in ionic form, so we can write those elements in which last electron enters in d orbital are called d block elements, or it belongs from d block. These are also known as transition elements. These are also known as transition elements. These are also known as transition element. If we go for general configuration, then the general configuration comes out to be n minus 1d 1 to 10 and ns 0 to. Very simple. whatever is the cell number of S, the D will always be lesser than 1. Like if you have 4s2, then you will have 3D. Is that clear?
So,
Okay, please do right. Let me know when you are done with this.
done, sir.
Okay. Now see this periodic table. This is I took only D block in which you can see the scandium, third, fourth, fifth group, sixth, up to 12th group. 13th group is your P block started. Okay. Now, so the first one, this is your 3D series. This is called 3D series, or you can call it first transition series. This is your 4D series, this one. This is your 5D series. This is your 6D series. And accordingly, you can call it second transition series. Accordingly, you can call it third transition. And accordingly, you can call it fourth transition series. And this is your 6D series. Is that clear?
Yes, sir.
Okay, so you can took a screenshot or you can take a printout to study D block because there will be lots of variation in this chapter. So be aware of this. Just wait a minute. Can you change the slide?
Yes, sir.
Okay, so one thing I'm going to do, I'm going to give you is that you need to do the electronic configuration of this: the scandium, titanium, vanadium, chromium, manganese, and then iron, then cobalt, then nickel, then zinc, sorry, nickel, then copper, and then comes zinc. And you know the atomic number, I think you know, and that is your, for a scandium, it is 21, 22, 23, 24, 25, 26, 27, 28, 29, and then comes your 30. And this is your 3D series. We are especially talking about 3D series. So you are going to do the configuration. Can you do this?
Yes, sir, I can.
Very good.
So we have to do it argon 3D1 like
Yes,
that.
yes. In that form, you are going to do it.
Yeah, okay, sir. I can.
Austin, we just started D block element. So we started from here, Austin D block. What is D block element? So an elements when you are going to do the electronic configuration and last electron enters into D orbital, that element belongs from D block. And these are also known as transition element. And the general electronic configuration is this. And if you are going to see D block, this is your D block in which scandium from here D block is started, and this series scandium to zinc is known as your 3D series. This is 4D, 5D, and 6D series. Austin, is that clear? Then very good. And then I gave this, which I'm expecting from both of you can do easily the electronic configuration.
So I'm done.
Very good. So how you did configuration? Argon, and you
Argon
know that 4s to
3D1
3D.
4S2.
Okay, so I'm going to write DD because this will be similar. Okay, and this become 3D3. But for this one, which is exception, which I'm expected from both of you to do the correct, this will be 4s1 3D5. It will be stable in half field. Then again, argon 4s2 3D 3D5. And then again, it will be following this 3D6, it will be. And then this is your 3D7, and then this is your 3D8, and then comes your copper in which argon, this becomes 4s1 3D10. There is in 3D series you have two exceptions which you need to keep in your mind, which is very important. And the last one, if you are going to see zinc, that is your argon 4s2 3D10. Also, this is very important to note that scandium to copper, these are all called transition elements, and this is your not transition element. This zinc is not transition element. So basically, what is transition element? I will explain first right in this. Let me know when you are done.
I'm done, sir.
Austin, please do respond. Okay. So basically, this is transition, about transition. Now I'm going to discuss what is transition element. So very simple it is. I'm going to write it. You can easily understand. Transition elements. Those elements which have partially filled d orbital, which have partially filled d orbital in their ground state, as well as most common oxidations. Most common oxidation. If it is in ground state, you can see zinc is completely filled. As well as if you are going to see zinc shows Zn plus 2. When it will be in Zn plus 2, so it will be argon 4s0 3d10. Still, it is completely filled. That's why zinc does not consider to be transition element. Whereas copper, you can see here it is fulfilled. But if you are going to see most common oxidation states U plus 2, it is your 4s0 3d9, which is incompletely filled, partially filled d orbital. That's why copper considered to be transition element. Is that clear, both of you? Whereas this point is very important. Zinc, in which you can see 3d10. Cadmium, you can see it will be in from 4D series 4D10, and mercury, that is your 5D series 5D10, have fully filled d orbit, have fully filled d orbit. So these are not considered as transitional. These are not considered as transition elements. These exceptions and these elements are very important for you. It is in a group, 12th group, zinc, cadmium, and mercury. So let me know when you are done with it. Let me know when you are done with this. So we are going to complete this D block, but with D block, I will be giving some questions to practice. So we are going to do questions in class as well. Let me know when you are done with this.
Done, sir.
Okay, Austin. No. See, now we are going to talk about atomic radii of 3D series. So you have seen in class 11 periodic table, there was strand from left to right. If you are going basically the size decreases. But here, if you are going to see this green one is for 3D on which now you are going to focus. And this color blue type is your 4D series. And this one is your 5D series. Okay. Just wait a minute. Okay. So you can see the first, if you are going to see this, what do we say? The scandium is bigger. Then the size decreases. Titanium, vanadium, chromium. After that, manganese slightly smaller. Then iron slightly smaller. Cobalt, they becomes almost equal. Nickel equal, and then size increases. Copper and then zinc. But still, if you are going to see clearly, this zinc is not bigger than this titanium. Okay, so you should focus on this. You should focus on green. Now, as you can see, whatever is happening here, I'm going to write as we move from left to right in 3D series. Atomic radii of 3D elements first decreases, then remains same, and then in the end series atomic 3D series atomic radii increases. Why? What happens? I'll write all of this. So first write it with me. As we move from left to right in 3D series, atomic radii of 3D elements, 3D series elements, atomic radii of elements first decreases, then remains same, and in the end atomic radii increases. What is the reason atomic radii increases? What is the reason? I will write it first right after this. let let me know when you are done. Let me know when you are done with this.
Done, sir.
What is the reason behind it? Because the reason is important. Because what happens in it? Wait. See, initially the nuclear charges increases. That's why force of attraction increases and the size decreases. We can write initially atomic radii decreases due to the increase in nuclear charge. Due to the increase in nuclear charge. In the middle, why it becomes equal? In the middle of the 3D series, in the middle of the series, the increased nuclear charge the increased nuclear charge and screening effect and screening effect balance each other balance each other and atomic radii become almost constant towards the end of the series. And here, towards the end of the series, atomic radii increases. Please do that. Due to repulsion in electronics, due to repulsion in between electron and please do that. Mhm. Let me know when you are done with this. Are you done with this?
Yes, sir.
No. Now we are going for magnetic properties. One by one, we will study everything. Magnetic properties already you know from coordination compound mu is equal to under root n into n plus 2. So basically, most of the block elements are paramagnetic. Unpaired electrons are there, are paramagnetic in nature due to the presence of unpaired electron due to the presence of unpaired electron. While zinc, which is 3d10, already told you, cadmium 4d10, and Hg, that is mercury 5d10, are diamagnetic. Are diamagnetic due to presence of paired electron. Due to presence of paired. Write it. Let me know when you are done with this. Have you read NCRT biomolecules? Very important it is. If you are not going to read it, you'll lose marks, and it's very easy. So, would like to give homework in NCRT. Every exercise question in text solved, unsolved plus exercise. Very important. You should do for every chapter as well.
Done, sir.
All of you done. Austin, very good. Magnetic moment, that is mu. Now, what is this magnetic moment? So basically, mu is equal to under root of n into n plus 2. That is your magnetic moment. Also, here its unit is bm, that is Bohr magneton. Bohr magneton. And n is basically number of unpaired electrons. Number of unpaired electrons. You have seen this formula in coordination compound. Calculate mu for following. Calculate mu for following. Zn plus 2 I'm going to give you. Cr plus 3 I'm going to give you. Cu plus 2 I'm going to give you. Manganese plus 7. Please do this. Let me know when you are done with this. Are you done with this?
So the last one is mn plus 7.
Yes.
Okay.
Any answer for this? As you can see, this will be argon. 4s0 3d10, that means paired, so mu will be equal to 0. If we are going for this, this will be argon 4s0 3d3, right? So 3d3, that means here you can see unpaired electron, 3 unpaired electron. So it comes out to be 3.75 or 3.8. So mu is equal to under root of n 3 into 3 plus 2, that is root 15. If you are going to do the configuration for this, for argon 4s0 3d9, and for 3d9 you can see 1 2 3 4, and here it will be 1 2 3 4 5 6 7 8 9, only one unpaired electron, and the root of 1 into 1 plus 2, so that comes out to be root 3. And here if you are going to do argon 4s2 3d5 is here, so 3d0, so it comes out to be mu equals to 0, right?
Yes, sir.
Now I'm going to give some questions from Amin's for last half an hour. In the next class we will be completing this chapter. Mhm. Please do this. Oh, please do this. I'll be back in a minute. Any answer? Oh, very good, Hamam. Any answer from Humam? You have given this answer. Very good. I thought it's Austin. Any answer? Humam three third. Okay, that is correct. Fourth one, and then comes fifth. Fifth one is C. Humam, fifth one is C, not D. Okay.
Okay, sir.
Then sixth one is sixth. You haven't done.
No, sir, I forgot.
Okay. So do it. And then comes your eighth one. Eighth one is D, Humam. D. That is good. Ninth A. That is good. 11 B. Remind me, I will explain this. 12th is mhm, 2 bromo amino benzene. No, not 2 bromo Humam. It will be meta. I will explain. Which one you have done wrong? That is the fifth. Then comes your 8D, ninth A, and then 10th. You have done wrong. 10th you haven't attempted.
No, sir, I couldn't get the answer.
11 is B, 11 is wrong, and 12 is also wrong. So see, I'm going to explain, Umam. Very simple it is. A, third is correct. The correct increasing order of basic strength. You know that this is your plus I, and you know that basic strength directly proportional to plus I. This is minus I, which decreases acidic strength. There is no plus I minus I. So third one will be the most basic. Then comes the first one. Then comes the second one. So the fifth will have an answer that is C, not B. You had given what? B, which is wrong answer. Now the sixth one, if you are going to see, which of the following reaction is appropriate for converting acetamide to methanamide? SC, that is common name we use for two carbon generally. Okay. And methane, that means one carbon. That means there is one carbon which is degrading, or you can see there is one less carbon than the parent. So it is basically Hoffman. Hoffman hydrobromide reaction or Hoffman bromamide degradation reaction. 10th one, if you are going for, this is the 10th one. Method by which aniline cannot be prepared is hydrolysis of. Now, if you are going to hydrolyze this cyanide, you will get amine. Degradation of benzamide with bromine water, you will get amine. Okay, because C double bond ONH2 is there. So this will be eliminated and this benzene amine. Reducing of nitrobenzene, if you are going to reduce, you will get amine. Potassium salt of halimide treated with chlorobenzene followed by this will be the answer. 10th B. Because aryl halide, that is AR, is not going to react with this substitution reaction. 11th, if you are going to see, some reaction summings are given on which one is not correct. NaNO2 is there, so this is what you will get. The correct answer will be this B, because secondary amines react with nitrous acid to give. This is your secondary amines, so it will not give benzene diazonium chloride if you remember. And 12, if you are going to see, you will be getting this OH will be replaced by Cl, and you will be getting this bromine will be here, and this becomes COCl. After this, if you are going to react with NH3, what you will get? If you are going to react with NH3, this Cl will be eliminated, and you will be getting amide, like that will be eliminated by NH2. And after this, if you are going to react this with NaOH-Br2, that means very simple. Hoffman degradation will be taking place. NH2, this CO will be eliminated. So M bromoaniline you will get. Is that clear?
Yes, sir.
Again, I'm going to leave this acidic or basic character is very important. Write it, do the question. Humam. 24th is Humam C, not B.
Okay, sir.
See, when you are going to react this benzaldehyde with aniline, you are going to to remove water, and this becomes CH double bond N, and this is your Skips base. Okay, not Skips reagent. Then the 25 is D, that is correct, and 32 that you have given. What you have, yes, it is D. So, Umam, in the next class, we will be continuing this D and F block on Thursday. We'll try to complete this. Then I'll see you in the next class. Okay. Is
Okay.
there any doubt you want to ask?
No, no, sir.
Okay. Thank you.